Hey everyone, it's Mrs. Dinkelman again. This is the beginning of Unit 7. We're going to start with use substitution, which is technically review, but we're going to learn some more techniques during this chapter, so I thought it would be a good idea just to remind ourselves about use substitution. So if you remember, use substitution comes from kind of undoing the chain rule, and sometimes you can avoid it, so don't think that you have to always use use substitution if you can kind of figure out what the integral is without it. As people ask questions in class, I will tend to say, which way would you prefer to do it? There are a lot of ones that I tend to avoid use substitution, and we'll talk about those. So just as a quick reminder, because we are undoing the chain rule, let's go ahead and take the derivative of these, just to kind of remind ourselves what it's going to look like when we see that it's going to need to be use substitution for an integral. So the derivative of e to the x cubed, what I like to say is it's e to the stuff and then times the derivative of the stuff. And so what you have to notice here, if we were kind of wondering if we had done the chain rule or not, is that we see the derivative of some inside thing happening. So with sine squared, what I kind of wish is we had parentheses and the squared was on the outside. If I could just borrow those parentheses. So here when I take the derivative, the 2 is going to be the outside. You leave the inside alone and then multiply by the derivative of the inside. For natural logs, what I like to say for chain rule is it's 1 over the stuff times the derivative of the stuff. Okay. So again, with all of those, part of what the reason I wanted us to look through the derivative is to see that piece of where the derivative is actually attached. Now I have an activity here that hopefully we'll be able to do in class. If you're not in class, then you can feel free to try that if you want. Otherwise, we're just going to go ahead and skip down to the steps here. So sometimes the hard part is finding the u. So look inside a radical. If there's parentheses, that's sometimes a really helpful way to figure out what u is. If there's not, think about where you might insert them because that can help you figure out what the inside is. We're going to take the derivative of u implicitly. Now I do implicit a little bit different than Mr. Spain did last year, so you'll have to forgive me as we go through. It looks a little bit different, but if you continue to do his method, that's obviously totally fine. We'll have to solve for dx because one of the things we want to replace is the dx at the end of our integral, as well as all the x's. So that's one way to tell if you've done something right, is that all the x's can disappear. There are a few u substitutions that are a little bit more complicated. We probably won't get to them much here, at least now, but there are some times where you have to take a couple extra steps. So we'll maybe talk about that at a later time. So that's why I said in most integrals there should be no x's after the substitute problem, because we can end up canceling with that dx. We integrate, and then there's the last couple steps, and it kind of depends on whether we have a definite integral, which is the ones that have the numbers on them, the limits, or if it's indefinite. So if it's indefinite, that's A. We have to return our answer to x's. If it's a definite integral and has those limits, we want to change those limits to u's. And technically it's optional, but often on the AP exam, and I know Mr. Spain was grading the free response and texted me about this recently, that there were 0 points if you did not change those limits to u. So it's just something we want to get in the practice of doing, even if we haven't done it before. So I'll walk us through that when we look at these examples. Okay, so on example 4 here, if I were to insert parentheses, I probably would insert them here, and it's e to the something. So another way to think about it is, what's the something? It's sine of something, or it's e to the something, or it's something square rooted. So generally that's also a helpful hint in finding what u is going to be. So u is going to be that square root of x. Now this is a little bit different one, and I picked this one because I see a lot of different things happening on it. So I'll kind of walk you through a couple different options here. So when we take the derivative here, I take the derivative of u and I put a du because that's how I learned how to do implicit. Whatever the variable is, that's what you put a d something. That's called a differential. This is x to the 1/2, so this is going to be 1/2 x to the negative 1/2, and because I took the derivative of an x, I put a dx there. So we have to solve for dx. Before I do that, because this is rather complicated, I think I'm going to rewrite it. So du is really 1 over 2 root x dx. That'll help me figure out what dx is. So dx is going to equal 2 root x du. So when we come to this integral now and replace things with u, some people replace this with u and this with u, which is totally fine. I would tend not to, and let me show you why, but then I'll show you what happens if you accidentally do that or if you just do it because you want to. So we're going to have an e to the u. I shouldn't have put the dx there because I'm going to replace it. I'm just going to put a 1 there, and I'm going to think of the dx as being off to the side. So here's why I didn't. What I noticed is that that root x and that root x were going to cancel. So that's kind of why I decided not to change it. Now let's pretend that you did change it. Okay, let's go in here and erase. I'm going to go erase this because then that's not going to cancel. So you accidentally or just on purpose put the u there. And then what you notice is things don't cancel like we have normally see. Well, I also still have an x remaining. So if I go over here, I can also see that root x is equal to u. So I could just replace that with a u. Accidentally took the 2 away as well. But then again, the same thing happens. I end up being able to cancel those u's. So what we really have for this integral, I like to move the constants out in the front since we're allowed to. This is e to the negative u. So it's going to be 2. And for integrals, it's going to be e to the stuff. And instead of multiplying by the derivative of the stuff, we have to divide by the derivative of the stuff when we have an integral. I'm going to go ahead and use this space, and then I'll have to erase it. So our final answer, because our question was in x's, our answer should be in x's, should be negative 2 e to the negative root x plus c. Okay? All right. So let me get rid of most of this so we have a space for the next one. Oops, I don't want to get rid of that wrap up. Okay, so for the next one, might be a little bit trickier as far as finding u. So one of the things I'm noticing about that one is I see natural log, and then I also see that there's technically a 1 over x in there. That x is in the denominator. Well, that's the derivative of natural log of x. So that tells me here that I think u should equal natural log of x, because when I take the derivative here, I'm going to get the 1 over x dx. In fact, some people at this point say, oh, this dx and that x on the bottom, those just become du. So they don't even solve for dx. If you're confused about that, continue to solve for dx. It's not going to make a difference. But if we're in a little bit of a hurry or we just have a lot of complicated steps, that's one kind of way to cut down on the number of steps. So dx then is equal to x du. So I'm going to write this integral. I'm not going to worry yet about these limits just yet. So that's going to be u over x, and I'm going to have x du. So what I'm going to notice is these cancel. All right, let's talk about plugging in. So these, this e squared and this 1, those are technically x's. We're going to plug them in for x eventually, but what we want to do really is plug them in over here and see if we can change them to u, so we don't have to do that last step where I was over here changing back. So if I have ln of e squared, ln and e cancel each other out. I'm just going to write that here off to the side. So u equals, and ln and e are inverse functions, so they cancel each other out, and I'm just left with 2. So now that new limit is 2. And now I'm going to plug the 1 in there. So u is equal to ln of 1. ln of 1 is 0, so 0 to 2. So here's what I really have. Now I'm just going to write it a little bit nicer. From 0 to 2, the integral of u to u, and u squared over 2. From 0 to 2. I do not have to go back to x's because those are actually u's. In fact, when you get to some higher levels of calculus, when you have multivariable, sometimes professors will ask you to write x equals and u equals right here so that you know for sure what variable you're trying to plug in for. Okay, so 2 squared over 2 is going to be 2 minus 0, so 2 is our final answer. So I think one of the tricks and one of the things that we're going to have to work on, because we are going to have lots of different techniques in BC, is how do we determine when this strategy should be used or would be used? And again, that's sometimes a little bit different for different people depending on if they can just see what's happening versus they kind of need a procedure to make it work. So one of the things I would say is really important to notice when it's going to be a U substitution problem is that you see a function and you see a derivative of something else attached in there, something related to it. That way we know for sure we're going to do U sub. That'll help us a little bit when we get to what's called integration by parts. So feel free on this assignment as you go through, feel free to avoid U substitution. So if you just know what's happening, that's totally fine. Just go for it and take the integral. There are a couple where I ask you not to evaluate, and I just want to make sure that you know how to change the limits basically, or to rewrite them. So just go for that and try to just remember to change those limits. Good luck.